Hi, this is Mr. Mitchell with a video on gases and the gas laws. One key aspect of gases is the concept of pressure. Even though gases are invisible, they do have force, which means they have pressure. And you can feel that pressure and force if you squeeze a balloon. The pressure of the air inside pushes back. So there is some kind of force with gas. Like most anything in physical science, pressure can be measured, and it has a formula. Pressure is force over a certain area, and it's calculated in newtons over meters squared, which makes for pascals. The unit for pressure is called pascals. And you can see a sample I have here. If you have 40 newtons of force on 5 square meters, that would be 8 pascals. So it's just a simple matter of having the correct unit and putting things in the right place if you were to use the force formula. There happen to be 3 gas laws. I'd like for you to understand their principles. Now, they're going to be named after people that came up with them, but I don't know that in this class you have to memorize which one is Boyle's law and which one is Charles's law and which one is Gay-Lussac's law. I think I want you to know the concept of all. So here are the concepts, and this one happens to be Charles's law. One concept is what happens with gas and changes of temperature. For the law on this slide says that as temperature rises, gas expands. So if you have this balloon and the gas inside it, the temperature rises. Say it is brought to a different place or put near some sort of heating source, the gas inside expands. So if you have an enclosed something like a balloon that can expand, the balloon will expand as the temperature rises. And that's what happens whenever a balloon goes up and down in the atmosphere. There are different densities around it, and sometimes it will expand and sometimes it won't. And, well, I should say different temperatures and densities around it. And this concept, as the temperature rises, gas expands, is also the reason why hot air balloons work as they do. If you have any familiarity with hot air balloons, you know that someone in the basket here is going to pull something and it lets go, it releases fire and a lot of heat that goes up into the hot air balloon. So as the heat goes into the balloon, the gas expands and the balloon rises. Now, I have a very small little thing right here, and what I want you to be able to see on this is that we have this concept of these green things are molecules. Now, you may remember that gas has molecules and that they are farther out and moving faster than solids and liquids. So if you add more heat to it, then just like you would expect, they would move even farther out and they would be moving even faster. So that's kind of the kinetic law that fits very well with this. If you do have a rise in temperature, then gas particles are going to move faster and the heat is going to cause it to expand. So that is one of the principles that has to do with temperature. Another one has to do with temperature also, and this happens to be Gay-Lussac's law. As the temperature rises, the pressure increases. So as we had here, the gas expands, you also have an increase in pressure. You should have more pascals of pressure inside this balloon and inside this balloon as the temperature rises. This is also, well, you can see an example here. You have the temperature is one thing, and then when the temperature rises, not only do the molecules inside this container go faster and heat up, you have more pressure. Now, what's going to happen with a balloon? The balloon will expand, which will take a little bit of pressure off. But if you have a container that does not expand, like a Coke can is a little more rigid. So if you put more pressure on it, then you just have more, if you pour more heat on it, then you just have more pressure in it. Now, you may have noticed that this is upside down in some ice. So if you have that the temperature rises, the pressure increases, the opposite is going to be true. As the temperature goes down, the pressure decreases. And there happens to be an experiment where you heat up a can, get the pressure real hot, real high, and then quickly put it into the ice. And what will happen is it will kind of implode. You can see that it is not circular anymore here, that the pressure around it is now so much more because with the cold temperature, the pressure decreased. And that happens to be one of the principles. And a final one, which happens to be Boyle's law, has to do a lot more with volume and pressure. So here it says, as the volume of the gas decreases, the pressure increases. Now let me say this again. As the volume of the container decreases, the pressure increases. So if we have a balloon here, we have the same amount of gas in it, and we suddenly decrease it, then you still have the same amount of gas in it. That means there's going to be more pressure because the little molecules that are in there have less space in which to move around. So that kind of makes sense, and it's also the reason why we have bubbles. If you have bubbles that are in the ocean, they're going to float up, and as they float up, they get bigger, because the opposite happens here. In the ocean, the pressure is going to decrease as the bubbles go up. So that means the volume will increase. You'll have a bigger area. So you have this bigger area of the gas of this bubble that is going to be floating up. And that sometimes gives divers some troubles, sometimes gives fish troubles that are caught in the depths, and the internal organs have bubbles, have a bubble in it, and it's going to increase as it comes to the top. But those are the three main concepts. One of them is, as temperature goes higher, the gas expands. Another is, as the temperature goes higher, the pressure increases. And a third is, as the volume decreases, the pressure increases. So I want you to be able to know these concepts more than you know which particular law it applies to. Hope you learned a little bit about gases, pressure, and gas laws.